Hi, my name is Derk van Veen. Today I will be talking about Postgres partitioning. This is my Postgres partitioning cookbook based on the past 4 years I've been building this experience with Postgres partitioning. If you are working with Postgres and you need to start with partitioning, this is a really good starting point. Right, let's open today's partitioning cookbook and see what I have for you. I've been working with Postgres partitioning now for 4 years. And when you work on something, you see it everywhere around you. I'm pretty sure you know this. And for me, this is the most cool example about partitioning, and I never expected to find it there. For me, the masters of partitioning are the supermarkets. They do partitioning everywhere, and it's so cool. Like if I enter my supermarket, first there is like the fruit and the groceries, or the fruit and the vegetables. But they are splitted. There's the fruits and there's the vegetables. And then next to it, it's like canned food. But within canned food, there's more partitioning. The things they want to sell first are at eye level. And the things they don't mind selling are at different levels. And then even within a single tray, there is more partitioning going on. The cans they need to sell first, the cans that expire first, they are in the front. And the things with a later expiration date, they are more to the back. And for me, that is such a good example of all the things you can do with partitioning. And it's just nice how a technical concept you can also find everywhere around you. And for me, that's something that makes partitioning really cool to think about. Like, how can I optimize all these things? I'm not running a supermarket, but I do have a lot of data. Try to imagine a supermarket where there's no structure. So you enter the supermarket and there's like chaos everywhere. And then you have like your index map and you look like X. Maybe track 6, fourth rack, and then somewhere on the top. And if not, go to the 6th or the 7th lane, and maybe it's somewhere there. Could be disaster, right? So how can we organize data with partitioning? That's the most important thing for us as database experts. So why would you start partitioning at all? Because let's be honest, it's a hassle. It is more work. It's probably gonna hurt performance at least a little bit. And it's not gonna make things easier. It's gonna make things more complicated. Well, the most obvious reason to do it is the table size. Postgres has a physical limit of 32 terabytes. If you want to hit that limit and then think about partitioning, you are way too late. I would say if your tables are around 100 gigabytes, that's a good moment to start to think about partitioning. If your table grows to 100 gigabytes, not 100 terabytes, when your table grows to 100 gigabytes, your table's gonna grow probably also towards terabytes. And then it's already a little bit late to start to think about partitioning. So I would say 100 gigabytes is a good moment to start to think about, how do I want to partition my table? Or more importantly, how do I actually want to partition my entire environment? Because you can't partition a table by table. You have to partition all tables together. Because when your table gets too big, maintenance becomes really hard. And we don't like really hard tasks, right? We want life to be easy. And to keep maintenance under control, to keep vacuum timing under control, tables need to be nice and compacted and not too big, because then vacuum will take forever and that's no good for anyone. And finally, data lifecycle management with partitioning is so much easier. Usually when developers think about cleanup, it's a cleanup job and it runs once a month, then it starts to run once a week, and then it runs once a day. But every now and then this cleanup job fails, you need to debug it, you need to deploy it again, you become delayed, it becomes a hassle, right? But with partitioning, if data's old enough, you just take the partition, you drop the entire partition, and all the hassle is done. That's the way you want to do data lifecycle management with partitioning. So for me, these are the reasons to do partitioning. And there's only one good way to do partitioning in my perspective. And that is range-based partitioning. I know you can do hash-based partitioning and list-based partitioning. And especially developers usually love hash-based partitioning. I hate it. Because developers might say like, but yeah, then the insert logic, it's It spreads the load across all the partitions and it will be really fast. But at the end of the day, all the data needs to go to a disk, and that disk is not that good at completely random insert. And even more important, a hash is random. And if you have a lot of random inserts in your indexes, that's really bad for performance of your index. And you have to do a lot of maintenance work on the indexes. And if that's not enough for you, what if you have 10 hash partitions and you need more partitions? You need to go from 10 to 20. Suddenly, you need to redistribute all of your data, and you're doing partitioning, so you have a lot of data. That means you have to rewrite almost all of your data. That's a disaster. So, range-based partitioning is the only good way to go, at least in my opinion. So instead of one big table, we have just chunks which are smaller. And the most natural one, I would say, is date ranged partitioning. So in this example, I could just store data for the first 3 months of this year. And if I'm collecting PII data, I see like, oh, this data has been collected in January 2026. So in 5 years' time, I can easily drop this partition and all my PII data will be gone. That's how easy partitioning can make this task for you. But we are working with a relational database, so we have a lot of relational data. That means probably you use a integer type as your primary key. I would say that's a high probability. And then probably you want to partition on this integer type because the partitioning key has to be part of your primary key. Otherwise, we can't enforce the uniqueness over all partitions. And there's one more thing. You can have a default partition. And I have mixed feelings with default partitions. The default partition is kind of a catch-all, which is really convenient because it means by definition you cannot run out of partitions. If I try to insert value 5000 in this partition table, it ends up in the default partition. No harm done, application keeps running. But then what do you do with this default partition? Because suddenly I can't create a partition anymore from 5000 to 6000 because that means moving data around from a default partition to other partitions. So it's also a little bit of a trickery. And in Postgres 18, if you look at the partitioning constraint for a default partition, it will say default, and that's it. But if you have older Postgres versions, I don't know when the switch happened, but the default constraint used to be listed as not all of the other ranges. And that's really problematic. So the default partition, it can be a lifesaver, it can be a blessing, but it's also definitely a curse. Because locking with the default partition is really hard. If I need to add a partition, I need to change my partitioning constraint on the default partition. That means I need an access exclusive lock on my default partition. That also means I need to wait for all my transactions on the cluster, hence the cluster, not the database, to finish to get that lock. So that can be a really long waiting time for a very simple operation, and that's why I don't like it. But this is where the default partition has been a lifesaver for me. I had multiple tables in completely different ranges, and they were all feeding into one bigger table. That bigger table, that was the one growing, so that one needed partitioning. But how can I partition this big table? If I partition this one from 0 to 1010, I cannot have partitions in between. So how do we solve this? Well, I created this big table. I made it my default partition. That means I can have a constraint that is not all of the other constraints, right? And on top of that, I added a check constraint saying like all data in this default partition will be between 0 and 10, between 100 and 110, and between 1000 and 1010. And that means I can now create new partitions next to this partition. And these smaller partitions, they will catch the new values coming in. So I can store my values between 10 and 20 here, and between 110 and 120, etc. So this is where the default partition saved my life, or at least it made my life a lot easier. But yeah, you have to be really, really careful with its usage. And this is my favorite part of partitioning. And this is also where most people get nervous. Because when I'm working with partitions, I cheat a lot with the catalog. And I agree with you. Cheating with the catalog is a bad plan. But if it's the only option you have, why would you not do it? Just be aware that you need to be careful, right? So I have a partition table here with just a few partitions. Now, sometimes I need to do work on one of the partitions. Maybe there's a cleanup I need to do. Maybe there are corruptions. Maybe, I don't know. Over the years, there have been plenty moments where I needed to detach a partition, do some work on it, and then attach it back. So what I do, I detach it. Detaching is easy. Detaching can be done concurrently since Postgres version 14 from the top of my head, but only if you are not having a default partition. Remember how hard it is to change the constraint on the default partition. But now, if I want to add a partition back, the Postgres will enforce that all the values within this partition are not violating the partition boundaries. That means while I add this partition will be logged by Postgres and all the values will be checked if it's not violating the partitioning constraints. So I don't want to have this long-lasting log. So what do? I create a check constraint saying like all values in this partition are exactly matching the partition boundaries, or at least not violating the partition boundaries. And I add this check as not valid. Why do I add it as not valid? Well, that means I have no locking time. And if I want to validate my data in this table, I can do that. But I can also just update my catalog. And this is where the cheating comes in. And this is dangerous because I can put any value in this table and then attach it as a partition. But it's also a way to attach a table with data in just the time it takes to do a catalog operation. Because adding a table as a partition, strictly speaking, is just a catalog operation. It's just be careful. I created multiple incidents with this technique. Maybe my developers did it on my behalf, but I created the sources for them to do it. So be careful with it, especially at the boundaries. The lower boundary is included in the partition, the upper boundary is excluded, and that is where the mistakes came in my case. I actually included a row with ID 2000 in the second partition, while it should have been in the third partition. And when you ask for the data, you cannot find it unless you do a select all from a given partition. Be careful, but still, this is the best way I can think of to do these kind of operations really fast and without any locking. And then also this one, a lesson I learned over the years multiple times. But every operation you do with a partition table, adding indexes, foreign keys, detaching a partition, attaching it back, it all changes the structure of the partitioned table. And let me give you an example. I just have a partition table T1, stupid name, I know. If I want to add indexes to this table, if I would add the index on the parent immediately, I cannot add the index concurrently. It's not allowed on partition tables. But what I can do is create the indexes concurrently. And I start at the oldest partition and then I work my way up all the way to the top. And only when all the indexes are in place on the partitions, I add the index as well to the parent. So I enforce all the new children also to have this index. But that's also a problem, because if I want to drop this index now, I have no way of dropping this index easily. I cannot drop concurrently from the children, and I can also not drop concurrently from the parent, because it's a parent table, it's not allowed. So dropping indexes from a partition table can be really hard. So be aware what you are doing. And this is another example where I was really surprised. I have two tables here, two partition tables, and I have a foreign key between these two tables. And then again, I needed to do some cleanup on one of the partitions, and I did my trick. So I detached the partition from its parents. Then I was copying rows out, doing stuff in, all good. And then I attached this table back to the parent. But what happened? Suddenly, I have a lot more foreign key references between these tables. First, I only had a reference between the parents, and now suddenly I also have references between children individually, because I created a foreign key on a table which was not part of the partition table, so I changed the structure. Be aware of all these kind of unexpected behaviors with indexes, foreign keys, constraints. Just be aware. And yeah, probably no need to tell you this, but manage your partitions automatically in one way or the other. You don't want to do this manually. You will be successful, the developers love it, and suddenly all you do the entire day is managing partitions manually. Don't go there. All right, next part, joining tables. It's the hardest part of partitioning, I would say, because there are so many ways to go wrong with partitioning and joining partition tables with each other. So let's say I have two tables, a payment table and a ledger table. And we are doing a lot of payments within Adyen. Adyen started as a payment service provider. So we have a lot of payments and we have a lot of ledgers. So if you join a lot of partitions with a lot of partitions, that's a lot of work. If you want to save work, I always tell people the fastest way to do something is don't do it at all. The fastest way to read from a partition table is to only read from the partitions you really, really need. So in this case, I'm joining payment and ledger, and I'm searching for a specific ID. So this ID can only live in one partition for the payment table and one partition for the ledger table. So this is what I want. Well, good, right? Nothing wrong. But now if I make my where clause slightly more complicated, I expect it to read from two payment partitions and from two ledger partitions. But instead I'm reading from all the ledger partitions. And in this example, my slide is only 3, but in reality, this might be 50 partitions. I don't want to read 50 partitions. I want to read 2 partitions. So how do we fix this? Because this is a really big problem. Because if I don't fix this problem, my query gets more expensive with every partition I add. That's not what you want. So what is the solution here? You have to align your partitions around your leading figure. So you have to pick your leading figure. Pick one from history you like the most. No, that's not gonna work. Okay. So we are doing transactions, financial transactions within Adyen, right? So for us, the leading figure would be a financial transaction, a transaction in this case. And that ties together the payment, the ledger line, and all other kind of things related to transactions. So for me, for my system, the leading figure would be the transaction. For your system, it's probably a different column. But if you have a lot of tables with the same primary key, most likely that is your leading figure. And then the trick is to align all your tables. I will say it again. You have to align all your tables around this leading figure. And I will show you why. So here's the payment ledger example again. We know this is very inefficient. But let's see what happens if I align my partitions. So what do? I have to make my ledger partition slightly bigger and then pick exactly the same upper and lower boundary for all of my children. So now it looks already visually more appealing, right? And this also counts for Postgres, because if I now have data in one partition, I immediately know then the data I'm joining is exactly on the other partition. And that counts for the first one, the second one, the third one. And this is where the efficiency comes in. So let's see what happens. If I now do exactly the same query, it still doesn't work. We are getting nowhere. Well, hang on with me for just one more minute. I will show you, because there's one more trick we need to do. We have to set enable partition-wise join to on, because it will make the planning of joining with partition tables a little bit more expensive. But you pay a little bit of planning time, but execution time, you're scanning 2 partitions instead of 50 partitions. And that is going to save a lot of logs. You will save a ton of time on your log manager, and you're saving a lot of time on scanning partitions you don't need. So this is the real lifesaver. And with this setting on, and I run my query, finally, this is where I only reach from the partitions I really, really need. And this is how you gain maximum performance with partition tables. This is the trick. But I know how this goes. Sometimes you have a associative table between two tables. So in this case, between transaction and ledger, I have a transaction ledger table. How do I fix this? Because if I want to join a transaction with a ledger, they are not even partitioned on the same column. So this query will be expensive by definition. There's nothing I can do. So how can we solve this problem? And this is not an easy one. I totally agree with you. But all we can do, and all you can do, is this. You have to denormalize the ledger table. There's no other way around it. You have to include your leading figure with the ledger. So in my case, the transaction has to be included in the ledger table. That means I need to change my query. I need to check my query logic. And this is a lot of work and a lot of hard work. It's complicated, but the difference in performance, it's huge. So if you really want to maximize performance, this is the step you need to take. So finally, a little bit about archiving your data, because that's the final cool thing about partitioning. That's what I told you at the beginning, right? So very briefly, go through. I always have a table with at least 3 available empty partitions. Why? I hate to run out of partitions when I'm trying to insert something. And over time, partitions will fill up and I will create new empty partitions. And then after a while, my table will look like this. I have a lot of filled partitions and still I have a lot of 3 empty partitions to go for the future. Let's say this is the set of data I really care about. That also means now I have one partition I don't need anymore. So what to do with this one partition? Well, if this is just logging data and this is more than 10 days ago, I can just detach this partition and throw it away. No harm done. But sometimes I don't want to throw data away, but still I don't want to keep it in my primary system because it will slow me down. So what to do with this single row? Well, if I can't throw it away, but I don't want to keep it in this system either, I have to find another solution. I have to archive this data. So I can just have a big archiving database. I copy my data there. And if I really, really want to make this transparent to the application, I can even have a foreign data wrapper pointing to this archive data. But I will discourage you from doing this. It's a lot of work to maintain this. It's easy for me to draw an arrow from, hey, I have a primary system here and an archive here. Just have a foreign data wrapper. But in reality, this is a lot of work. It's complicated and a lot of ways to keep track of. So I would tell your application developer, this is your job to keep track of. But it is possible within Postgres to do this. So, summary. In my opinion, there's only one correct way of partitioning, and that is range-based partitioning. Hash-based partitioning, I strongly discourage you of using it. It is dangerous with respect to performance, and it's really dangerous when it comes to scaling. I know there are really cool solutions around where hash partitioning is the solution, but then you have to be extremely aware of what you are doing. And if you're just starting with partitioning, I think that's not where you are and not where you want to be. So please hear me out. Start with range-based partitioning. It's really much easier to handle. And then find the leading figure in your data. The leading figure is the one data unit bringing all the tables together, and that's what you really need for efficient joining. If you are not partitioning your tables all together in your environment, performance is gonna degrade over time dramatically. And that's gonna be really painful to fix. And finally, partitioning is also really good about data lifecycle management. Just detaching a partition and dropping the table, it's so much easier than a cleanup job. So if you know you're storing PII data, partition it by a date, get rid of it. Even if you store this by a integer type primary key, have a way to calculate how old the newest data in a partition is, and after that moment, you can throw your data away. It's really, really easy. If you want to have a quick start about partitioning, we have a partitioning framework. It needs some love, but still, I think this is an amazing start to build your own partitioning framework. I will try to update my partitioning framework again, but no promises there. I'm kind of busy. If you want to read a lot about partitioning, I published together with my colleagues 5 blogs on the topic, and maybe a sixth one, but it has a slightly different name. But that is a really good starting point where all my learnings about partitioning are listed. So I hope this is a really good starting point for you to learn about partitioning. It's a lot of background knowledge if you want to have a full read on the topic. And now I wish you all the luck with your partitioning journey. Have fun.